Welcome everyone to this week's video. Today we are on Fish Friday number 156 and we have a good one for you today. Today's video is basically a build off of that very special Fish Friday number 150 where we talk about fish morphology. That video got quite a bit of support and people seem to enjoy it, so I believe that we are going to start talking more about fish morphology. This video is a direct, it's a video that is directly answering one of the questions in the comments of that video. And that video, in that question was, do fish hear? There was some other caveats in that question, but essentially, do fish hear? And I want to make it very, very clear. Do fish hear? Yes, they do. Ask any angler on how to spook a fish, and usually noise is the number one thing. People say don't be too loud or you'll spook the fish, and that can certainly be the case. But let's talk about kind of how they hear. Essentially, how they hear, if you can see here, it's very similar. This is the otolith structures or the ear structures of a fish, and if you've ever seen the diagram of a human ear, it's actually fairly similar to humans in a broad sense. Yes, they hear. This would be the front of the fish and this would be the rear of the fish. So they have these tubes right here, which are very important for the fish to determine how it's oriented and how it's accelerating versus, is it, up, down, is it tilted side to side? That's what these canals are for. It has this inner ear that's located just behind the eyes. But you might be asking, well, what about the outer ear? We have our outer ears. And if you are unaware, the outer ear of humans is there so that air vibrations get trapped and are focused down to the inner ear for our inner ear to process, going down to the cochlear bones. The cochlear is basically an evolved form of this lagina system right here. The lagina is kind of like the super inner ear of the fish. Fish don't need an outer ear like humans do. And that is because sound travels better through water than it does through air. And a fish's body is about the same density as water. That's why fish don't have to worry about pressure to the point that humans do. And we'll talk about how fish equalize pressure in a future video. But essentially, just think that the fish's body is the same density as water, meaning that there's not really that density. Meanwhile, humans are significantly more dense than air, and it does not travel through our bodies like it does through air. So that is why we have this focusing organ, the outer ear, to focus the air vibrations in there. The fish are much more they're in their environment, they're absorbing the sound directly from their environment, and so it's the same distance. So the sound travels through the water and it will travel through the fish. So they don't need that focusing organ like we do, because it can actually physically travel through the fish itself. And that's how the sound travels through the water, through the fish to its ear. That's why they don't need this outer membrane. That's why their ears are, you can't, unless you are you actually know about the fish morphology, it's actually fairly hard to impossible to know where the ear bones of the fish would be, because they don't have any external structures to indicate that. So we talked about a little bit about how they hear, but why do they hear? And this is the bigger question, a part of the video. Why do they hear? Well, the sounds in the environment give the fish information about what's going on around them. Before we go on to that, I need to go back actually, how they're hearing. These white structures in the ears are what are called otoliths, which are called, essentially ear bones. And that's what's really determining the sound. Fish otoliths come in an extreme wide variety of structures. In fact, you can sometimes tell genus down to species, or family, genus, and species, based on the morphology of the otolith. So you can see all these different otoliths. Now, granted, these are fossils, I believe. So it's a little bit different. These are, rocks, but there are differing structure. Otoliths look very different from place to place. And we've talked about otoliths before, and fish scales being, I've talked about how fish scales have been used to age fish, and it can be effective, and if someone knows what they're doing, but otoliths are significantly better for determining age. So you can see right here, I found this picture with an otolith that has been prepped for age dating, and you can see easily these rings are there. And that is because the otolith grows very much like a tree. In terms, when it's growing, every time it deposits minerals, it gets bigger and bigger. So the otolith continues growing throughout the entire fish's life, never stops growing. But in times of quick growth period, you're going to have these spaces right here. And then in hardship times, when they're not getting as much nutrients and they're not getting as much minerals from the water and from food, the layers get more tightly packed. That's why you have these rings. That's why the rings on a tree. So when you see the light and dark alternating bands, those dark bands are actually usually periods of extreme drought or of winter time, when they're not growing, when they go dormant. And so they are still growing, just at a very minuscule rate. So that's actually extremely tightly packed growth rings together. So that's the same thing going on here. I should also note that otoliths have been used very successfully to look at where the fish has been found, due to the microchemistry of the otolith. So essentially they take a laser, that's a huge basic sort of thing, but they will basically determine how the minerals in the bone, moving from here to here, different levels of minerals like strontium, things like this, and that will help them determine where that fish has traveled throughout its lifetime. So otoliths can be extremely important for human research, as well as being extremely important for the fish. And the bone also helps them with orientation and things like this. But let's go kind of back to why they hear. So sounds in the environment give fish information about what's going on around them. And you might say, well, how? Is it like echolocation, like dolphins and bats and things like this? And in a sense, maybe, but at the same time, you use sound to give yourself information about what's going on around them. And the best way I can think of it, talk about this, is think about when you're walking across a street. You are, doing your own thing, and you hear a car off to the side. You are aware of that car. You are aware that there is something over there, so I should not walk in that path, or I should look to determine where that's coming from. So they're listening for threats. You listen for threats. So you're listening, you're taking all the sounds that are incoming from your ears and saying, that is not a sound I have to be aware of. That is a sound I need to turn and look at. That is a sound that I need to avoid. So you are doing the same thing that fish do. You're just doing it hopefully better. Determining that's a car, that's a chainsaw, that's, a guy yelling. The fish is, there's a loud noise over there. Do I investigate it, or do I run away? So they're listening for these threats, and they can actually hear quite well. Fish have no problem hearing. Fish can detect frequencies at much better frequencies than humans do. Not all of them, but a lot of fish do. And in fact, one of the one fish in particular, shad, marine shad, can actually detect frequencies extremely higher than humans. And they possibly have the best vertebrate frequency hearing in the world that we know of. And it's actually believed that the reason why they have such good hearing at that frequency is so they can listen for dolphins and be able to avoid dolphins. It's an evolutionary mechanism to avoid being predated upon. So they have there. So they're detecting the sensory, they detect the pressure densities, the differing pressure densities of the sound waves in the water. So hearing is critically important there. I should mention that the lateral line, we've talked about the lateral time numerous times, which detects differing densities in the water. It's a pressure sensing organ. That also can detect deep vibration sounds, but they have a limited range. Lateral lines, I believe, only do to like 5 to 10 lengths away from the fish, whereas these hearing bones can actually detect sounds from much farther away. Just like, you can feel a sonic boom on your skin, but your eardrums are going to explode. That sort of thing. That was maybe a little dark. But I should also mention that fish use sounds to communicate with each other. If you've ever been fishing and you've caught like freshwater drum, things like this, they're relatively noisy fish. And why would they make this noise if they can't really hear? And that's because they actually use sound to communicate with each other. I should also mention that some fish use their swim bladder as a hearing aid. Some fish will actually use the air contained within their swim bladder, and it's connected to this structure right here to actually help this structure hear better. It's a hearing aid. It amplifies the sound because it's banging around on the inside of that swim bladder. So, kind of to answer some of the questions on that video, can fish hear people talking through the aquarium? Can people hear them talking from the boat and things like this? Yes and no. If the person's being fairly quiet, it may not travel through the water. If you're right next to the aquarium, they can probably hear, but it's not going to startle them, even the one talking from the boat. Because these fish might be used to those sounds. And I found a really good analogy when doing this was, think of it if you are at a party and, music's going, people are laughing, talking, having a great time. You're not differentiating the sounds, what's a threat and what's not. There's so many sounds going on that you become attuned to them, basically. But if you're in a library, it's nice, quiet, everyone's studying, then all of a sudden you hear a loud bang. What happens in your library and you hear a loud bang? Everyone turns to look. Well, think of it the same way from a fish. If you're on a very quiet lake and, there's not a whole lot of activity on the lake and things going on, the fish are going to be much more aware of any sudden change in sounds. So everything's, good. If it's basically like, if the fish are there, then all of a sudden you start a boat engine semi close to them, they're going to be startled from that. That is why sometimes it's better to have an idling engine than constantly starting and stopping. In terms of the trolling motor, the trolling motor is usually more of a constant hum. People are trolling along the side. So they just become accustomed to that sound. Basically, it's like, okay, well, it's not a sudden difference. The sudden changes is what startles a fish. Startles. Slamming boat hatches and things like that. So if you are in an aquarium aspect, talking to them might be fine, but tapping on the glass, that's why they may startle when you tap on the glass or shut the lid a little hard and it slams it and scares them. So, you don't necessarily have to be quiet around the fish, but sudden loud sounds are what are going to startle them. So, but kind of go back to the boat aspect. If you're on a heavily recreated lake, there's water skiers and this and that. Fish are going to be much more sort of accustomed to the sound of the day. So they're going to be much less startled by sound. You're on a quiet farm pond, nearest humans 2 miles away. You're on a little John boat and you're fishing, everything's quiet. And then all of a sudden you drop your phone to the bottom of this metal John boat and it goes bang. That's going to startle the fish. But you're on, there's this lake in Texas called Lake Dunlop, which has water skiers and wakeboarders all the time. They're going back and forth. Everyone's hooping and hollering, music's blaring and all this. If you're fishing, you don't have to worry about like closing the door hatch, because think about it. I haven't done anything that should startle a fish more than what's been going on around me. So, yes, they are hearing you on the boat, but I would not be as concerned about talking or trolling. It's, should I slam door hatches? Look around. Are there 1,000 other boats on this lake of water? Okay, maybe I shouldn't slam shut. Shut the hatch instead of slamming it shut. There's 1,000 other boats on the lake. Make all the noise you want, because I guarantee you're making less noise than the other people. But thank you guys so much again. I really appreciate it. Hope to see you again. If I don't, please be safe. Have a great day. Please leave a like, comment, subscribe. If you do, I'd really appreciate it. Hope to see you again. Please, if you'd like to support the channel, please click the link down below. It is by no means expected, but very much appreciated. Regardless, take care of yourselves, take care of your loved ones, and peace.